Good afternoon, ladies and gentlemen, and good morning to our speakers and our attendees who are watching us from Europe and from America, and a good evening to our viewers from the Far East. On behalf of IED Communications Limited, organizers of the Automation Expo 2021 and the FieldComm Group India Society, I'm pleased to welcome you to the webinar on developments in Ethernet-APL and HART technologies. Our speakers today are Mr. Paul Sirico, Director Marketing and Product Strategy, and Mr. Wally Pratt, Director of Field Communication Protocols. IED and FieldComm Group have been associated since its inception through the Automation Expo. We've had Mr. Ted Masters and Mr. Paul Sirico from the FieldComm Group who have graced us with their presence in the earlier Automation Expos, and they have enriched the delegates by participating in their technical conferences. Before we go on to the webinars, I would like to give you a short introduction on Automation Expo. Automation Expo is the 15th edition that will be held from the 22nd to the 25th of September at the Bombay Exhibition Center. Our Automation Expo 2019 clocked in 1,005 exhibiting companies from 25 countries and 625 booths with 37,004 unique visitors and 47,894 visits. Automation Expo is all about networking, technologies, and business growth, and this time it will be bigger and better, bigger in size and better in prospects, since 2020 was missed due to COVID. Automation Expo will showcase all technologies, products, systems, and solutions that the industry needs, and that the new mantra of automate and digitalize will be the focus. FieldComm was first showcased in India by Automation Expo, and we are proud to invite all of you to the Automation Expo where FieldComm will exhibit their latest technologies. As you see now, this is the list of our 46 Board of Governors. It is our privilege that we are associated with the head honchos of the automation and instrumentation industry. We have a steering committee of 7 members who meet every fortnight. As you see, the next list of 18 impressive list of users as well as manufacturers of the automation industry. And this Board of Governors meet every fortnight to discuss how we have to make the exhibition bigger and better. And this year, the 15th edition, it's all about making the expo bigger, better, and stronger. And post-COVID, one has realized that today we need to automate and digitalize. And that's what you're going to see at the Automation Expo 2021, Networking, Technologies, and Business Growth. As we see, this is the Automation Expo is Southeast Asia's largest automation expo. It's a complete industry spectrum focusing on process automation, factory automation, industry 4.0, industrial automation, AR, VR, cyber security, and data analytics. Everything that is under the umbrella of automation and instrumentation will be showcased here. There are 4 concurrent events that we have, beginning with the CEO Summit on the first day, an IIoT seminar, factory automation roundtable, and emission control systems conference. And there's a lot more new. Every year we keep adding new things at automation. So what are you going to see new this time? An interoperability zone, emission monitoring pavilion, industry 4.0 zone, system integrators pavilion, a career connect, and why you should visit. More than 20,000 plus products. Enrich your knowledge. Network with who's who in the industry. And for the first time, a buyer-seller meet is being planned. As I said earlier, automate and digitalize, the new mantra in the post-COVID world. So it's a new world, same platform, and more opportunities. 4 Power Pack days beginning from day 1 to day 4. So be there, mark your calendars, and make sure that you are there, either as an exhibitor, visitor, or as a delegate. And for more information, for updates, please log on to automationindiaexpo.com, bigger, better, stronger. We also invite you to connect to our LinkedIn page, and you can get regular updates at the Automation Expo. Now I hand over to Mr. Harish, And Mr. Harish will now be introducing our speakers for the day. Mr. Harish is the Vice President of Chemtrals Industries Private Limited. He heads the Terminal Automation Division. He's also the Secretary of the FieldComm Group India Society. Prior to assuming the responsibility of national sales and marketing for this group vertical, he has held various profiles in project management, marketing, and sales and corporate management. He has over 35 years of experience in the field of process control and instrumentation, with a 15-year experience in Hendershauser before joining Chemtrals. He's also held key responsibilities in various key account management, solution business, and he has started his career as a project manager for Nivo Controls, an Indore-based company, a part of the Toshniwal Group. Mr. Harish is a postgraduate from Birla Institute of Technology, BITS Pilani, with a specialization in marketing from DAVV Singapore, DAVV in Indore. So thank you, sir. And now I hand over to Mr. Harish.
Well, thank you. Thank you very much indeed. And without much time wastage, I would say, let me just get on to the presentation of today. Let's get going. Well, I'm really happy to be a part of the FieldComm Group India Society and also the FieldComm Group as the regional director for marketing here. And as you are all aware, FieldComm Group is a global standards organization, which encompasses 3 major technologies, that is the HART, the Foundation Fieldbus, and FDI. We have a very active chapter in India, which constitutes of Anupam Srivastava, who's from Emerson, Weber, who's from Pepper and Fuchs, who's the vice chairman. I'm the secretary, and my colleague Ravindra Goyal, he's the CEO of EIP Instruments and the treasurer of the society. Well, I would recommend and urge all of you to be the members of our Indian chapter as well. We have 2 memberships, the corporate membership, which is actually a paid membership, whereas the end users membership is a free membership for all the people. Please get in touch with any of us and we will make sure that your name is in. Well, I also have the honor of introducing our speakers of today, Paul Sereco, who is the Director of Marketing and Product Strategy. In India, we have a term called guru, that means a person from whom we learn. Paul and Wally have been our gurus to us, and we hear them many a times, and I also learn a lot from them. He's a key strategist, and for that matter, also helps in marketing the technology worldwide. Wally is the Director of Field Communication Protocols, and many of you would be happy to know he's the architect of HART and wireless test systems. So he's a person who's I would say a brain whiz for the technology, for the HART technology. And well, I'm really delighted in welcoming him today to today's webinar. So without much ado, let me hand over the controls directly to you at Texas, Wally and Paul.
Good morning, everybody. Well, actually, it's good afternoon. We are coming to you, Wally and I are coming to you from Austin, Texas, where it is 5 a.m. So it's very, very, very early, and thus I'm talking with my early morning voice, but I'm going to get revved up here in a second and start speaking about our very exciting topic today. Thanks a lot. We're going to get started here. As Harish mentioned, I'm Paul. Wally and I are coming from Austin, Texas, and today we're going to talk to you a little bit about some new things that are going on. We always like to talk about new things, but we're also going to sprinkle in some technology that's been around for a little while, and we're going to talk about how these things are evolving in the in the world of digital transformation. So let's get started. So, hold on. So as Harish mentioned, we are from FieldComm Group. FieldComm Group is a member organization. We have about 390 members worldwide. We're responsible for some of the very familiar technologies that you all use in your facilities: HART, wireless HART, Foundation Fieldbus, and HART IP, which you use but you might not know you use. PADIM, which is a new technology for creating universal information models, and FDI. We've been around since 2015, and we were the our predecessor organizations were the HART Communication Foundation and the Fieldbus Foundation. So today I want to share with you some of the technology initiatives that we are taking up in FieldComm Group. About a year ago, we did a very extensive market analysis of the direction that the process automation issue is taking and how we need to develop new standards or adopt new standards to be relevant in that market, as well as to continue to preserve the investments of our membership in the technologies that we've marketed for 30 plus years, HART and Foundation Fieldbus predominantly. So we got together and we did today I'm going to start and talk to you a little bit about technology directions, and then we're going to talk about a couple of technologies. The first thing we're going to do is speak about technology called Ethernet-APL, which is two-wire powered Ethernet that's going in intrinsically safe Ethernet. And then we're going to talk about HART IP and wireless HART, and we're going to leave the last 15 minutes or so for a Q&A session that we can answer. So let's set the stage. Let's talk about what's going on in 21st century process automation. One of the driving factors that we find and that we've used for our strategic directions is a model that has been created in Germany by the Namur organization called the Namur Open Architecture. And what the Namur architecture does is it really has two kind of guiding principles. The first principle is do no harm. So don't interrupt existing process control. It works just fine. We can enhance it over time as technology evolves, but don't do anything to disrupt what's already working, what's already good in the gray box on this slide called core process control. Rather, let's add to what already exists through interfaces that prevent problems with interrupting the core process control, but yet provide data into monitoring and optimization layers that are defined by the Namur Open Architecture. So this is specifically plant-specific monitoring and optimization, as well as centralized monitoring and optimization across multiple facilities. So in the Namur Open Architecture has defined how they would like to see this happen in process control systems, process automation systems, and has served as kind of a spotlight for companies like FieldComm Group to develop standards towards. So we looked at the Namur Open Architecture and within the scope of our current technologies, and we said, well, okay, well, we've got some really good current technologies and basic technologies that we can build on. Wireless HART, HART, handheld terminals that you're all used to familiar using, and recently FDI, which is our entry into the device integration space. But those are not enough to really create all of the things that are needed for digital transformation and for the industrial Internet of Things, and to implement the Namur Open Architecture specifically. We need to add a few components to this mix. So first of all, we want to simplify. So the needs here are shown in black. We first need is to simplify the application development with a common information model, and we're doing that. Largely through adopting a couple things like that are OPC UA based. One of them is PADIM, which stands for our Process Automation Device Information Model. And what that does is it will enable any OPC UA enabled host or enterprise system to gain instantaneous access to read-only data from the field device down on the plant floor. That technology will be demonstrated later this year, and we expect to see products supporting it probably in 2022. The second thing we need to do is come up with some ways for incorporating, allowing easier access to cloud and to cloud applications and things like that. And we've done that with a technology called device info, which works with HART devices, as well as with PDM, and also using FDI as a gateway to as FDI technology as an integration technology to allow this data to transfer and be set up and configured in a much simpler way. By doing this, we then suddenly have the ability to add a lot of technology, a lot of data and information into private clouds, public clouds, business systems, and address new use cases for device data that's aligned with things like the more open architecture. This essentially is the top red rectangle from the prior slide on the more open architecture. Additionally, we have to do some things with security. Obviously, as you're deploying things, as you're allowing access into the cloud, security becomes a very important aspect and element of this. And there's also a new physical layer that's coming out called Ethernet-APL, and I'm going to talk to you quite a bit about that in the next several slides. So what we've when we boil all of these things that are on this chart down into some strategic initiatives that we want to work on, we came up with the following major objectives. First is industry-wide cybersecurity alignment, and what we're doing there is we're partnering with organizations like Profibus, Profinet International, ODVA, and the OPC Foundation in developing kind of a common framework for cybersecurity in the process automation industry. We want to work on HART for the 21st century. There's a lot of HART devices out there. People are going to continue to be developing HART, but new technologies like wireless HART and HART IP drive demands for different types of configuration tools, different levels of security, and we're enhancing the HART specifications to accommodate all of that. We also want to work on promoting this idea of a single device integration solution, namely through FDI. FDI itself is not a protocol. It's primarily a packaging technology and a client-server technology that allows for much easier configuration, offline configuration, system updates, maintenance, etc. And a lot of asset management systems are starting to support FDI, and we have a lot of FDI device packages continually being registered at FieldComm Group. And beginning in October of this year, any new device coming into FieldComm Group for registration will, in addition to be registered for its protocol like HART or Foundation Fieldbus, must also be registered as an FDI device. Finally, our last initiative is this notion of IT-friendly device data, and this is where technologies like OPC UA and device info, which is based on JSON or XML, come into play, because they are protocols that are OPC UA and JSON and XML are protocols that are a lot easier for IT organizations to understand, and they're not, whereas HART and Foundation Fieldbus are not necessarily, the most common names in the IT world. So the idea here is to cross the OT-IT chasm, because OT, operations technology, they tend to understand automation protocols, Fieldbus, DDs, that sort of thing. Plant IT understands things like asset management and Ethernet and security, and enterprise IT is all about analytics, of course, more security, and enterprise-wide resource planning. And data tends to be lost. We all know this. Data is lost in translation across these systems. Electronically, information does not move through the various layers, and semantically, information moves, but the meaning is misinterpreted or lost in the translation from one system to another. So all of the things that we're working on within FieldComm Group are designed to address some of these problems and make life easier for the end users like yourselves who are responsible for maintaining, managing, commissioning, installing, and operating these complicated systems. So the first technology that I'm going to talk about is Ethernet-APL, and then I'm going to turn it over to Wally to discuss HART IP and wireless HART. So what is Ethernet-APL? Well, you're going to hear a lot about it if you haven't heard about it already. Ethernet-APL is the process automations industry's answer to allowing the deployment of IP-enabled field devices within the process automation industry, thus bringing a single communications protocol, IP protocol basically, from the instrumentation on the plant floor all the way up to the enterprise. And obviously there's a lot of unique factors that are unique to the process automation issue that need to be addressed. And that is the reason that Ethernet up until this date has not been deployed widely on the plant floor. So the number one things, the kind of the mantra here is it's 2 wires. It gives 10 megabits per second. It's intrinsically safe, and the 2 wires also provide power for the instrumentation. And this really fills a gap. So as you can see from the layers going top to bottom, enterprise management, supervisory control, real control, and field network, Ethernet technology has been used in all but the bottom layer for actuators and field devices. And so this has been there's been a missing dedicated Ethernet physical layer for the field, and the requirements that need to be met to make that happen is, at least on the physical layer, is intrinsic safety, 2 wires, power and data, and obviously a robust network. And if we can achieve this in a physical layer, then it opens the door for application layer protocols like HART IP to take it the rest of the way by providing secure communications and modifying the command structures in ways to take advantage of the high speed that's being enabled by these by this new technology. So the goals of Ethernet IPA were to address the demands of the process industries: long cable distances, easy and robust connections. The connections are the exact same connections that you've used previously in Foundation Fieldbus and Profibus PA. Provide power and communication via one cable, and make sure that there is a intrinsically safe front end on all devices, hardware basically, that provides for protection methods and explosion in hazardous areas using intrinsic safety techniques. To develop the Ethernet-APL physical layer, 4 standards organizations shown on the right: FieldComm Group, ODVA, Profibus, Profinet International, and the OPC Foundation joined together with a dozen suppliers of technology, who in turn worked with several silicon suppliers to create a component that can be used to achieve the objectives that we described above, and that is about to come to fruition. Ethernet, just to reiterate a couple times, Ethernet-APL is a 2-wire Ethernet for process automation, and it's fully based on IEEE and IE standards. Ethernet-APL enables value generated by your product to be increased by bringing Ethernet technology and high-speed communication out into the field. Think about how much time you can save commissioning and configuring a device that's operating at 10 megabits per second versus one that's operating using a traditional 4 to 20 milliamp plus HART layer. And Ethernet-APL also enables the use of putting higher speed protocols on top of that physical layer, like HART IP. So you don't have to learn a new technology. You just have to take advantage of the physical layer that's going to be presented to you. So what we get with Ethernet-APL is it's a trunk and spur network. You can have 1,000 meters of cable length from what's called a power switch, which is in the upper left here, down to field switches. And those field switches can then have 200 meter segments between the 200 meter cable runs, excuse me, between the field switch and the instrument. And because it's an Ethernet network, and we all know that multiple protocols can run on Ethernet networks, there's no reason, physically at least, why a plant can't use common wiring, at least at some levels, to support Ethernet IP, Profinet, HART IP, all in the same network. So if there's instrumentation or if there's plant integration that needs to happen across different automation protocols, you can do that with Ethernet-APL. I'm not going to go into the details on this, other than to say that everything is based on either IEEE standards or IEC standards, or standards that were developed within the Ethernet-APL project and will in the future be approved as IEE standards. It's operatable in all zones and divisions, and there's optional intrinsic safety at the device level. Again, we use a single twisted pair, and the decision was made to do this because it allows for reuse of existing Fieldbus Type A cable. So if you happen to have a facility where you're considering an upgrade and you happen to want to go to Ethernet-APL, you can always replace your existing instrumentation and I/O with Ethernet-enabled instruments and Ethernet-enabled field switches. Now, it remains to be seen whether or not that will actually be the case, but clearly for greenfield opportunities, for plant expansions, using Ethernet-APL as a technology beginning in 2022, 2023 is something that you should clearly be considering. Okay. This is a very technical slide that shows how we do the intrinsic safety and where the intrinsic safety is placed in the network. But an important takeaway from this side is that one of the things that is a key to Ethernet-APL is this notion of port profiles. So what that means is that the individual switches that are in a specific Ethernet-APL network, some may support lower power, some may support higher power devices, some may have separate power. So there's a lot of flexibility that can be done so that the company that makes a high power consuming flow transmitter doesn't have to abide by the same power requirements that a little temperature transmitter might need. The architecture allows for the mixing and matching of different power profiles within the platform. It's very interesting. We've been working on it for many years. I've been on the marketing team for this, and Sean Vincent, who is our director of technology programs, he's been leading the Canoa Conformance Initiative within the APL project. We will be launching the technology, and there will be initial products available during the second half of this year. The official launch is scheduled for the ACAMA Pulse event, which is a large German trade show that's virtual this year, and that will be happening in mid-June. And there will be commercially available products available at that time, with many more to follow afterwards. So that's all about Ethernet-APL, and please put questions about Ethernet-APL into the question panel on the screen, and then I am going to turn it over to Wally Pratt, who's going to lead us through the HART IP and wireless HART sections of this presentation. Wally, over to you.
HART IP's actually been around for quite a while, and it's been largely invisible. For those of you that perhaps are as old as me, or maybe even a little bit younger, you remember back in the late 1990s, almost everything connected to the field was via RS-485. Around the early 2000s, we were developing wireless HART, and we really needed something easier to use as a backbone to connect to remote I/O. Remote I/O kind of in the early 2000s was a major revolution. saved a lot of plant costs because it, moved the I/O out to the field. And so in 2007, we started working on HART IP. And so we enabled it via the OPC server. And so all the backbones to wireless HART gateways are all HART IP. We did the first field trials with HART IP in 2009. In this time frame, this was really just a series of application notes. Now it's fine for the time being. Became a formal spec in 2012. In 2020, we released a version 2 of it, which added specified very specific security requirements. To be clear, security was always required. We just didn't specify which security. This dovetails in very well with Ethernet-APL becoming released. And so between the two, we're really setting up so that we can move from HART IP using just an I/O to being used in field devices. HART IP is like HART. It's actually a fairly simple approach. We took the industry standard IP protocols, Internet Protocol Standards, TCP and UDP, and we put a thin layer on top of those, which is a wrapper for HART IP. And inside that wrapper is the same HART communication packet that's used in HART 40-20 milliamp devices today. And likewise, that's the same HART application layer used in HART IP, used in wireless HART, and used in HART 40-20. So all the tools that you're used to using work pretty much out of the box with HART IP because it's the same application layer. This very thin layer, we inserted security. We're using industry standard IP security. And we've adapted it slightly to make it a little easier for you to use. We use pre-shared keys, for example, rather than certificates. And so this is very similar to the Modbus TCP approach, where you put a thin wrapper around the protocol and embed it in Internet Protocol. And like everything on the Internet Protocol, we don't care what physical layer it runs on. Today, lots of places in I/O. I mean, HEMA's safety systems have used HART IP as a way to talk to their connected devices for years. It's well supported in Delta V. Honeywell has got RTUs that use HART IP. Phoenix Contacts and others have remote I/O using HART IP. And so it's supported by all these systems. And today it's supported for both doing monitoring optimization, plant asset management, and even control. So HART IP communication really is a client server architecture, and it supports really two kinds of communication. One is cyclic communication, which is publishing of process and status data. This uses the same HART burst mode concepts that were used since 1990 in HART 40-20, but we're just making these a lot more predominant because we're pushing the data, and pushing the data is a much more efficient way of operating than polling all the time. Of course, the normal acyclic polling, like you see using plant asset management systems, is also still supported. And we require all HART IP devices to support up to at least 5 clients. So we don't care what physical layer it is. You have multiple clients. Typically, we see this allows for redundant controllers, publishing data to a data historian, operator consoles, and a plant asset management. So these 5 clients gives you kind of the tools to the typical kinds of things you're doing in your plant. Smart data publishing was introduced about 2007, and the concept was, rather than drowning you in data, let's make the data that we provide to you, done in a smarter way. So the evolution is really of HART since the late 2000s have been to publish everything by exceptions. One of the key concepts here is all these devices are time synchronized, and so there are timestamps on the published data, so you know when the measurements were actually taken. Likewise, if there's status changes, for those of you familiar with HART Command 48, those are pushed if the status of the field device changes. The smart data publishing means that you send the data, for example, when the process gets above a threshold or when the process gets outside of some window. So the whole idea is it's the same paradigm we use with current loop, wireless HART or HART IP. And, you know, HART's got the data with 45, 50 million devices. HART IP really is an enabler to make it easier to get this data and push it up into your hierarchies. If you look at the opportunities here, the real opportunities for you and your plants, as well as, you know, members that are making products, is to focus on this monitoring and optimization paradigm. People are not taking and ripping out their control systems on a regular basis. Rather, they're letting the control system do what they do well, and they're augmenting it with more monitoring and optimization applications. HART IP is a really good fit, being IP-based, to address these measurement and optimization opportunities. And it dovetails well with APL, because APL, being a relatively simple 2-wire cable with good speed, also is a good complement to this monitoring and optimization. And since it's based on the Internet Protocol standards, pushing this data through data diodes and what have you up into a central operation where you're doing analytics on your plant as a whole, again, really good opportunity here for you. And we encourage you to start thinking about how enhancing your monitoring and optimization can improve your profitability and improve your uptime of your plants. Next, I'm going to spend a few minutes talking about wireless HART, another technology that's somewhat invisible, but really another really cool technology. When you step back and think about today's HART, it really is the same basic application layer running on multiple different kinds of backbones, multiple different kinds of physical layers. HART 4-20, everybody knows this. We're still going to see a lot of HART 4-20 sold for the foreseeable future. Wireless HART is really a pretty unique technology. It's super reliable, very secure, self-healing mesh network. So this again is a really very innovative technology, same application layer. And then HART IP, which doesn't really care what the physical layer is, coexists with lots of other technologies, either talking through a satellite, talking over Ethernet, talking across, you know, cellular network. So we've got a nice diversity of solutions that all use the same application layer and all use the same tools that you're already used to using. So what we're going to talk about now a little bit is let's talk about the key parts of a wireless HART network. Of course, the really innovative part about wireless HART is the mesh network. The whole idea of the mesh network is there are redundant paths for the wireless communication to be successful over. And that's over, I don't know if you can see my mouse or not, this is over in this area here. And so the devices themselves all become part of the strength of the network. The network becomes stronger, more reliable the more devices you add, which is really kind of different than most technologies you think about. These are all managed inside this portal, this wireless HART gateway, by a network manager. Network manager is always getting reports of the health of the network, even the health of the radio frequency space near the individual devices. And as such, it can groom the network and improve it, and improve its reliability over time. Security manager is a key part of this. And then the gateway allows other applications to connect to the network. And the gateways are almost always wireless HART. I don't know if any that are not HART IP, excuse me. And it still works. The devices have maintenance ports, still work with the, you know, with the standard handhelds and PCs that you're used to seeing. So key parts here. Same tools you use today. We were very cognizant of this at the time, is we wanted you to be able to use your handhelds, your plant asset managements, your integration technology that you knew at the time. We want it to be very easy to install, and we'll see that in a minute. There's 4 basic rules. If you follow these rules, it just works. The other thing is we want needed super reliability. One of our keys to success has had to be very reliable, had to be very secure. And today, there's well over 40,000 networks installed, and we're seeing continued growth in the wireless HART space because it's easy to use, easy to install, very reliable. I mean, the reliability builds your confidence, right? So the network rules are really easy to remember. You got to have a mesh network, so you need to have at least 5 devices. The mesh network is really the strength of wireless HART. And then there's the rule of 3. Okay, make sure that all devices can talk to at least 3 other devices. Again, establishing the mesh. You want 25% of devices 1 hop from your wireless HART gateway. And then the rule of distance is the faster the communication you want, the closer you want it to the gateway. And so you can get very fast updates, but it's better, works better if you're closer to the network. And if you follow these basic rules, which are really pretty easy, it just works almost like magic. We're very, very impressed with the results. Okay. The reason the mesh is important is it was very clear that the radio frequency space is changing continuously. It's changing when you have vehicles running through the plant. It's changing when the temperature and humidity change. Lots of things, multipath fading changes dramatically based upon temperature, humidity, space, all these kinds of things. And so the mesh is the key because it continuously adapts to that. If you have a problem device, how do you solve it? Probably buy another device because you probably broke one of those rules. The other thing is if you look at a network and you see a device that's only 99% reliable, something's wrong. It should be much more reliable to that, and you should look at it. And that's kind of shocking. You're like 99% reliable is pretty good. Well, in wireless HART, we expect at least 4 sigma. So it's really important. And this is bared out with people like Ben over at Nucor Steel. I mean, he was just kind of blown away. And this is typical. You know, this really shocked him that it worked much better than expected. Works better than expected, and the way the mesh forms is not obvious. The way us humans think, it's not the way the radio frequency space works. And so the mesh network is really powerful in that way. And it saves a ton of cost because you don't have to run any wires. Security is extremely important here, and we have defense in depth, and this is really good strategy security. The layers of trust is established using a join key. The join key is write only. Nobody can read the join key, what's in the device. Once the device is connected to the network, that key can change, and then no human even knows what the join key is. And if you don't know the join key, you really can't eavesdrop on the loop. I mean, you can see that there's some communication, but you really can't tell what the communication is. The second thing is, even though it's joined to the network, we require a device to be quarantined. So this gives you defense in depth because not only do you have to have the join key, a human has to look at it and say, yeah, I trust that device. Okay, and we can even add access control lists, so only devices that you know well can join the network. So this whole idea of building trust is key to security. Of course, we use really robust AES 128 encryption. AES 128 encryption is rated by the US government for up to secret level of communications. So this is a very robust communication encryption method. It's used in banking systems even today. It's part of the TCP/IP stack in terms of standard security thing. So a lot of in-depth security because it's wireless, anybody can listen. Really great, again, addressing this monitoring optimization because it's really cost effective, it's really easy to install, very long battery life. 5-year battery life is not unusual at all. And then you're connected to HART IP, so you can get the data to the cloud. I mean, for example, the OSI Soft Pi Data Historian natively knows HART IP. So Really a powerful enabling technology. And I want to share with you a few case studies about wireless HART, and we'll go through these fairly quickly. First, we've gotten some feedback from people like ARC Advisory Group, which is an international, study group on trends. And the interesting thing here, I think, is we're seeing a lot of growth here in wireless HART as a percentage of HART shipments. HART shipments continue to be over 4 million devices a year. But what we're seeing is a larger and larger percentage of the total HART shipments are becoming wireless HART. You say, oh, it's only 4%. Well, 4% of 4 million devices is a lot of devices, folks. So as this continues to grow, so does wireless HART. So we're seeing again, there's a lot of these case studies are unusual in that most people won't tell you they're using wireless HART because it's become part of their way to differentiate and improve their plant operations. And so they don't want to talk about that, but some people have shared it. So it's, again, very solid growth. Lots of good reasons for this. Low cost, really easy to install. Data's great, very cost effective, and of course there's no wires. We've had one interesting thing, which HART protocol already supports, is one of the actual problems some plants have is they lose their devices. Since the devices don't have any wires, they can see the device is producing the data and they're getting the data up to the cloud. But sometimes the maintenance tech actually has problems finding the devices themselves to work on them, even though they're working. So kind of an interesting unintended consequence of wireless communication. But it just works good. So let's talk a little bit about Nucor Steel. It's 2014 Plant of the Year. We have Plant of the Year awards every year for people that show outstanding evidence of the benefits of FieldComm Group technology. I believe last year, the year before, I think it was a Reliance or somebody in India. Don't get me lying. So, but this is a big deal. The companies that achieve this and get this reward are really, really proud of themselves, and they should be. So what Nucor Steel is trying to do is they have, this is definitely a brownfield installation. You can't just go out and chip up concrete, run new conduit. It just doesn't work. They had some issues with their water usage and they needed to monitor that. And they found that, wireless was 50 to 80% lower installed cost and 100% data reliability. The number of shutdowns that they've reduced and documented the number of shutdowns they've reduced is truly impressive. They've saved a lot of money. As they've done with wireless HART, and you see this all the time, once they do something and it knows it works, they start adding more stuff. And so now they're running differential pressure on their bag houses so that they can more intelligently schedule when to clean those bag houses. They were monitoring temperature and vibration on overhead cranes, which avoids shutdowns. And they don't need the wires on the overhead cranes to do it. And since the cranes are not moving extremely large distances, the mesh network, it just takes care of it, So they're really pleased with the results, very measurable benefits. At last count, wireless HART covers 90% of their plant. They've got multiple gateways, lots of wireless devices, and it all ties back in using HART IP over their Wi-Fi backbone. They're not running Ethernet to the gateways, they're running Wi-Fi. And so this is, much easier than they expected. Easy to get the data. And again, shocked that it works. In some cases, the wireless HART communication works better in these canyons of steels around the plants because the way the communication bounces off some of that steel, the mesh forms around that and it actually improves the reliability. And that's just really not obvious when you first start the journey of using wireless HART. And then we have a number of different case studies where people have said, hey, I've got an operating plant, but I need to get a better handle on fugitive emissions and monitoring our fence lines to prove to ourselves and our neighbors, that we are good neighbors, that we don't, send out, hydrogen sulfide or other even more radical elements out of the plants, that we're being good stewards of the environment. And a lot of these cases, the wired instruments have a little bit of a problem because of corrosion, and so a environmentally sealed wireless HART device with a battery tends to actually work really well, and it reduces the costs because there's no wires again, and you don't have to shut down the plant to do it. So really a big deal. In other cases, this is a case where somebody took over a tank farm and went in there, and they needed an easy way to bring up the instrumentation and environmental monitoring up to the standards that the company expects. And so wireless HART, again, was a really fast way to deploy gas detection and other things and get them up to the level of compliance so that they really are good stewards and good neighbors. We're seeing even in Asia and in India a lot of wireless HART activity for the same reason you're seeing elsewhere. It's very low cost, it's very reliable. You can do remote measurements, you can integrate it back into the systems, you can improve plant reliability because now you can add additional monitoring points at a relatively low cost. In many cases, adding more monitoring optimization, the cost of the wiring is prohibitive. And so things like monitoring pump seals and bearing temperatures and vibration monitoring and verifying that your safety valves are working properly. Adding, in this case, thousands of wireless devices and hundreds of gateways across multiple sites help them across the board in terms of plant reliability, plant uptime, moving to more of a predictive monitoring, predictive maintenance activities rather than reactive. All these things are a big deal when you look at, the cost of an unscheduled shutdown, for example. In this case, and this has been a big activity in the wireless HART space, is adding, monitoring steam traps, monitoring shutdown valves. These kinds of things are stuff typical plant people wish they always had, but they couldn't justify it because of wiring costs, because they may had to, had plant be shut down to run that wire. Wireless HART, again, is a big deal here to improve energy efficiency on steam traps, to look at your cooling systems on your water cooling systems and your and make sure that those are also reliable. Because if you have problems with your cooling water supply, that can lead to a plant shutdown as well. And then since you now can then merge all this data using HART IP, you can use higher powered analytics to look at the results of this because you've got more monitoring optimization points. And so again, wireless HART is really the killer application for monitoring optimization and then integrating it using HART IP. So that's kind of a little bit about HART IP and some of the exciting things people are doing. It's like most technology, it's an enabler, and what people actually do with it sometimes is pretty shocking and things you didn't really expect. And I'm really proud of the results that we did. We had a really good engineering team doing this, and it's much better than I ever expected, and you really should be looking at it. Paul?
Kind of conclude a lot of the webinars that I do with this question, whether it's targeted at our own members and suppliers or whether it's at users. And the question I ask is, are you ready? Because, digital transformation is coming. Do you have a digital transformation strategy? Do you know how you would like to take advantage of this? What particular applications might be beneficial to you? Are you considering beginning the journey to digital transformation in monitoring or in control, and how are your devices primarily used? Are there benefits to you in terms of commissioning and setup for these 10 megabit per second connections that come along with Ethernet-APL? Are you comfortable with an Ethernet-based field network? And if you're not, what steps can you take in terms of test beds or prototyping or whatever to become more comfortable, because this is the direction that the industry is heading. If greenfield applications are a large part of your future plans, or even if you're planning on introducing new technologies, if you're planning on expanding existing plants, probably a good idea to start thinking about some of these technologies. And what are your internal capabilities, your workforce and your training? Are they ready for this? And what are your long-term plans for modernization? And secondly, we talked a lot about, or lastly rather, we talked a lot about IIoT monitoring and optimization type applications on the left and top sides of the Namur application model, Namur open architecture. Are these of future interest to your business, and can you start documenting some of the things you'd like to do and presenting them to your suppliers? What we found in doing some end user viewpoints in some studies that I actually did one of these studies at Automation Expo a couple of years ago. What we found is that people are very willing to use a technology like Ethernet-APL or like wireless for something like monitoring and optimization. But as you go back to the more critical control things, you find that they're much more comfortable with 4 to 20 milliamp HART, and that's okay. Okay, it's familiar, it's something and that sort of thing. And that's the left chart here. And then the right chart here is kind of says the same thing in a slightly different way. And you need to consider in your own plant what your appetite is for adopting these technologies. And I'd encourage you to think about it by application area. Some companies are more, let's face it, some companies are more out there than others. Depending on the industry that you serve, you may have different answers to your willingness to adopt a new technology, how skilled your engineering staff is, what the consequences of a process failure, consequence of a security breach. And I would encourage all of you to kind of create a scorecard like this about your specific plants, and work towards closing the gaps that you see, like, can IT and OT work together? Figure out how to make that, how to close some of those gaps before you embark on the journey of adopting some of these new technologies, or work with your suppliers to figure out how to go about doing this. I'm sure they'll be happy to help. So that's the last of this presentation. I'd like to thank all of you for joining. Because of the way that we did this, I haven't seen what kind of questions there might be, but we're certainly willing to take questions now. Oh, I don't see any questions. So are there any questions?
Oh, there are many questions actually.
Mm-hmm.
If you like, I can read them out to you.
Okay, go ahead.
First of all, thank you, Wally and Brad. I'll read out the first question. There are about 10 of them. To begin with the first one, how the limit of 100-meter cable length of Ethernet is managed in APL. And generally, the field communication need longer distance travel for the process signal.
It's 1,000 meters.
Yeah, it's
from the field switch, from the power switch to the field switch, and it's 200 meters from the field switch to the instrument. So the instrument needs to be within 200 meters of a switch.
Yeah,
of course,
perfect.
you can daisy chain and extend that distance. So.
And there is a corollary question to that by Mr. Kurupaswamy, which says how to manage.
Go ahead.
How to manage when the distance is more than 1,000 meters and 200 meters per length?
So I'm going to say that this is accommodated in the specifications. There's also a very detailed engineering guidelines document that is being developed that explains how to grow networks and how to architect them, and so on and so forth. So we will, when that document comes out, I think those questions will be better answered. Yeah. Certainly better answered than by someone like me.
Well, I think one of the things you have to bear in mind is, this is a hierarchy of networks.
Yes.
The fields, the power switches are really expected to be, be connected to like a gigabit Ethernet backbone, and so the real question is how much of that cable is actually in the intrinsically safe area, and how much of it is, connected through a larger plant network. I mean, a lot of plants that I've been in, you got an Ethernet backbone all over the place. So what you're really talking about is how you get from that into the actual safe area. And so, it's in some ways kind of like, your typical IT strategy. How do you put together this large networks, right?
Yeah. Great. Then there is one more question which says, well, everyone is very keen to keep their legacy devices or the assets that they already have procured. So he wants to know how we can use our existing HART devices, but replace the upper layer to APL to wire or within APL switch channel controller to take an advantage.
Well, we have member companies. Wally will probably go into this, but we have member companies that are working on products that would do just that. So the low side of the switch would be 4 to 20 milliamp HART, and the high side of the switch would be Ethernet-APL.
I mean, it's the same idea you have with remote I/O today. I mean, remote I/O today, though, and a lot of times uses a proprietary protocol from that I/O back to the controller. If you look at stuff like the OPA forum is talking about is, let's use a standardized backbone like Ethernet to talk to that remote I/O. And there's already a lot of remote I/O that does HART IP. And so that's a small step from there to an APL based, intrinsically safe remote I/O. And I expect those.
Great. Then what speed can we expect with Ethernet-APL? Well, I think you've already answered that question while making that presentation. 10 megabits.
It's 10 megabits. It's 10 megabits. Yeah.
Yeah. Let me chime in here a little bit and try to put this in perspective. Okay. The typical numbers in terms of total load on a device, and this varies a lot because the devices need different power, but the total load is on the order of 50 devices. Okay. If you take and do nothing extraordinary, and you put HART IP devices on there publishing data at 20 updates per second, which is screaming fast, right? I'm sorry, temperature doesn't change that fast, only fast flow loops. But you do that and you calculate the numbers, you could have over 100 devices on an APL network, every one of them publishing 20 process variables, measurements a second. That's over double or triple what you expect to see based on the power load. So if you look at 10 megabits, you say, oh my God, well, that's a lot slower than 1 gigabit. But if you put it in the perspective of a process industry, that's screaming fast, guys. That's only using like 20% of the bandwidth. So there's still 80% for retries and plant asset management stuff. I mean, 10 megabits per second, guys, is really fast,
Yes. Truly, considering that the processes don't change so fast, really, as you just mentioned.
Yeah.
There's a question from Mr. Karthik. Sorry, there's a question from Mr. Karthik, which is also related to the same point. which says that isn't 10 megabits speed Ethernet inadequate compared to 100 megabits that's available on Ethernet already? So I think you just answered the question saying that, okay, the processes don't change. I think there is enough bandwidth available.
Well, and I think if you look at the state of the art in your process in the the last hop from your process automation device, the transmitter, to whatever it's connected to today, the highest speed you're going to get is what you'd get with Foundation Fieldbus or Profibus PA, and that's 31K. So we're a little bit faster than that.
Very true. Very true.
Remember, they're turning this to gigabit network backbone. This is really for the spurs into a process unit.
Right.
Yeah. Then Mr. Kurupaswamy has asked, is Honeywell also a part of the Ethernet-APL project?
They are not.
Okay. Then what is the battery life for these wireless sensors?
Let me clarify that a little bit. They are not. That does not mean that they won't be creating Ethernet-APL products. It's just whether or not they intended to join initially and help with the development of the specifications and things, which they chose not to do.
Then another question is about, is wireless really recommended for critical control applications?
I can point out.
Mostly it is monitoring as we.
I can provide you with bibliographies on entire books talking about doing critical control with wireless HART. There are plants in Austin that are using wireless HART for critical control. The fundamental issue you have with any communication scheme is how reliable is it. If you can get the reliability you need for control, then you can do the control. And so we don't toot our horns real loud on this. But, the fact that it's time-stamped data means you can move from being kind of continuously using data as fast as you can go to using an event-based control strategy, which is very viable. And when you do that, wireless HART does a really great job because you know what time the data was taken at. And so you can accommodate that simply by feeding in a computation of the manual reset function in all PID loops. So it actually works very well, but I could speak 4 or 5 hours on that. And so I'm done for the moment.
Well, yeah, and I will chime in as the business guy and answer and ask the question and answer the question a different way and say, well, it depends. It depends on what you're doing, what the speed is, and what the tolerance for your organization is to deal with an issue if there is a problem, which is the same in any technology. If you're running a brewery, the impact of a wireless network going down on during the middle of the fermentation cycle or something is a little bit different than if you're running a refinery. So the questions that I asked in that scorecard often will direct you to the answer that is appropriate for your organization, independent of the capabilities of the technology.
Great. There's a question from Mr. Sanjay. What about compatibility of wireless HART and HART IP devices to Internet of Things?
Well, you're already seeing HART IP adopted by people like OSI Soft Pi. They adopted HART IP support, almost a decade ago. And so
I'm not sure what the question actually is.
I agree with that, but I'm saying if you want to push data up into the cloud, which is kind of what IoT does, we've got a good story there. But yeah, what is Internet of Things, right?
Yeah, and we offer alternative technologies as well. So you could have a wireless HART or a HART IP device that they all can support device info files, which is a technology for providing information in XML or JSON format on some of the read-only commands available in HART. and that can feed your IoT system, as well as hard IP, raw hard IP data. So in other words, you don't have to have a cloud platform that understands HART to be able to take advantage of HART data.
Sure. Very true. I know technology may not really be the limitation, but how to really use that data.
Yeah.
Okay. One very important question which has come up is, on what basis the plant owners or detail engineering companies should decide between wireless HART, Ethernet-APL, or HART IP to have the most efficient and reliable operations, and not to increase the costs? I think it's a question of making what best mix is can be used.
Yeah, I'd encourage I've done a lot of work with a lot of national oil companies and large oil companies. I'm principally talking about oil and gas, but it extends to any other industries. I really encourage companies to embark on an effort to create a digital transformation plan that includes things like, what is your appetite for security? What is your appetite for IP on the plant floor? What applications would you do? How would you roll this out? What would you do to test it before you do it? And the answers, the question that you asked, the answers to the questions you asked would come out of that survey, because the answer is different for every customer. Well, not for every customer, but the answer is different. Okay. There's no one size fit all. There's no one size fit all.
It was kind of a calculus question, wasn't it?
Yeah.
Well, there are questions which I believe you've already answered. Why is APL only 2-wire?
Because 2 wires is less expensive than 4.
We will send him the copy of the presentation, so that should give them some idea of that. Okay, and who are the players working on APL switches that can interface to wire HART devices or HART IP devices?
Well, there's one that's on the board of the Ethernet of the FCGIS. That would be Pepperl & Fuchs, obviously. So. And there are others, obviously.
Many others. It's always hard for us to tell, because when you put out an open technology, people don't have to tell me what their product plans are.
And honestly, and the other thing you have to realize too, that if it wasn't clear, is that it's a switch. It's not. It doesn't have to carry a protocol. It doesn't have to carry an application layer protocol. It's a switch, So the switch, you can plug in a Profinet instrument, you can plug in an Ethernet IP instrument and a HART IP instrument all into the same switch. I'm not sure you would, but you can.
Yeah, I mean, it's just Ethernet, guys. It's the same Ethernet frame that you have in all the switches in your plant already. Just different physical layer.
Yes.
Okay. Well, there are another 5-6 questions, but let me just shorten them up. One of them is, just because of the paucity of time, how is full duplex communication achieved in Ethernet-APL using 2-wire?
I don't know, but you can. But the engineering guidelines and the spec and the specifications that will soon be published in about 2 months, if you can wait that long, we'll have those answers.
Yeah. And also a corollary to this is, is APL immune to EMI, that is electromagnetic interference?
That was one of the design principles of the APL group. They've done a lot of testing on that, and that's a pretty deep question that I can't answer, but I know that was one of their criteria.
Yeah.
And IEEE,
okay.
IEEE is the governing body, and they're big into all those kinds of questions.
Yeah.
Okay. One more question, and I think we will have to stop here. Is is there any distance limitation when it comes to wireless HART, or one can use repeaters and go long?
It's a mesh network. Every hop can be a couple hundred meters, you know, so you can spread out that mesh over a large area. You know, it just depends. It depends on your design criteria and what you're trying to achieve. You know, if you're putting in 100 temperature transmitters, you know, so you only need updates every 30 seconds, you know, you can go. I've heard people putting it down pipelines, you know.
Yeah.
Whatever.
It depends on the requirements of the applications. You know,
Yeah.
you could conceivably hop for a long way off of a pipeline, but you know, the data is going, if it's a battery operated instrument and it's, you know, 2 miles down the link, you're not going to get data updates every 10 seconds. It's going to be more like every 30 minutes. So, you know, you just kind of have to, you know.
Typically, there'll also be non-critical.
Yeah.
Another calculus question.
Yeah.
Okay. I think the others, I'll have to maybe send them the answers separately because we're running short of time. So let me pass it over to you, Weber. Thank you so much, Paul. Thank you so much, Wally, for answering all the questions. So over to you, Weber, please.
Thanks, Harishji. Great. I think it was indeed a great session. And let me begin by thanking Mr. Paul Sirico, Director Marketing, FieldComm Group of US, for not only taking this session, but also being a great support to FCCI India's all initiatives. So thanks a lot, Paul. I also think that Wally has explained things in a very nice and a simple way for the complex topic. So I would also like to thank Wally for great simplification of this topic.
Jyoti, can you come online?
Hello? Yes, Harish?
No, I'm requesting Jyoti to come online or put the camera on.
So I also would like to thank our communication partners for today's session, Mrs. ID Communication and Jyoti, and our Director Marketing, Harish, for all the hard work both of you have put in for this day. So thanks once again, and big thanks to our audience as well, who have shown a lot of keen interest. And I'm sure this is just a beginning, and I'm sure the time to come, definitely there will be many more opportunities for us to interact with Paul and Wally and their entire team, and hope to see you guys soon in India as well. So with this, I would like to close this today's session, and once again, thank you all for attending, and have a great evening. Thank you very much.
Jyoti, closing remarks.
Thank you so much, sir. Thank you, Mr. Paul. Thank you, Mr. Wally, Mr. Harish, Mr. Weber. It was a good session, and we look forward to meeting you at Automation Expo 2021.
Yeah, and if you're still on the line, please join the FieldComm Group India Society. They're doing great work, and you know, the great work is not possible without volunteers and members. And if you want to hear more of this stuff, please join.
Thank you, one and all.
Thank you.
Excellent. Bye.
Bye.